Before we get into systems of nonlinear equations, let's just have a review real quick of systems of linear equations. So if you need to, you can pause this video. We also did this exact same thing in Module 1, Lesson 2 at the beginning of its lesson. There are only 3 different outcomes that I can have when I have systems of linear equations. When I have 2 lines that I am graphing, you can either have intersecting lines, which means where they intersect is my one solution. So that solution is in the ordered pair of x, comma, y. If you have parallel lines, meaning these 2 lines have the same slope, then you will have no solutions because they're never going to touch, they're never going to intersect. The third thing that can happen is that we could have the same line. So we could have the same equation wrote in different forms, not realizing it. And so when I go to graph, it's one line on top of the other. So we have infinitely many. And I put a couple of the points on this line, but it goes on forever in both directions. So you have more points as this line keeps going. And also you have all of these little points in between my points. So we have infinitely many. Now, when I had systems of linear equations, these were my only 3 outcomes. Nothing else could happen, so it was kind of predictable in this manner. Let's go on to the next page. And now we're going to see that as my shapes change from lines, my outcomes are going to be different. So in this first one, example 1 says, graph each equation of a system, solve the system to find the points of the intersection. Now, typically we don't really like graphing because it has to be accurate, and it's only helpful if our solutions are whole number solutions. But it is a good visual representation about what's going to happen. So we're going to do one graphing to get a visual, and then we're going to do the rest algebraically, which is substitution and elimination. Now, whether we are solving by graphing or algebraically by substitution or elimination, these are kind of the same 3 steps you want to do every time. First, we want to identify what shape these make. Then we want to think about the different outcomes that can happen. And specifically, I want to know how many solutions could I have, because we're going to see when I have linear systems, we could have 1 or infinite. But as my shapes change, we can have 2, 3, 4, and so on, different solutions to one system. So we want to think about the different solutions, and then we will solve. Now, this is the only one we're going to solve by graphing, but the other ones will solve by substitution or elimination. So if this is my system right here, first identify this top one here makes what shape when we graph it. Okay, that is a line. If you have nothing squared, that is a linear equation. And what will this one right here make? Use that flow chart if you need it. That's a circle. You have 2 square terms, both positive and the same coefficient. So pause the video, and I want you to think about what different outcomes I can have when I graph a line and a circle on the same coordinate plane. Okay, I hope you had time to think about the different outcomes, or at least have time to pause and think about it. We could have 3 different outcomes with this one as well. We could have a circle, pretend like that's a circle. And we could have a line cross through it at 1, 2 different places. So here we could have 2 solutions. We can also have a line or a circle and a line that is tangent to the circle, meaning it's going to cross and touch it 1 time on that outer edge. And so here we would get 1 solution. And then probably the most common thing that's going to happen is I could have a circle and then a line that just completely misses it. So I would have no solution. Okay, so still 3 different outcomes. But this 2 solution one is a little bit different. And now I can see I don't have infinitely many. That's not a possibility. Okay, so now let's solve. So if we are solving by graphing, first, the easiest way to graph a line is to put it in y equals mx plus b form. So I want to solve this for y. And I do that by adding that x over. So now from here, I am told 2 things. First, I have that my slope is 1. And I have that my y-intercept is at 0, 2. So I'm going to go ahead and graph this. At 0, 2 is my y-intercept. And then I will use my slope of 1, which is the same as 1 over 1, to go up 1 over 1, up 1 over 1, up 1 over 1. And that is also the same as -1 over -1, because negative over negative is positive. So we can go down 1 to the left 1, down 1 to the left 1. And I know I have a ruler around here somewhere. There's my line. So now in a different color, I'm going to go red. I'm going to graph this one here. So we've already said this is a circle. So for circles, we need 2 things. We need the center and we need the radius. So my center, if I have nothing in parentheses, my HK is 0, 0. And then my radius, this equals r squared. So the square root of 4 would give me a radius of 2. So I'm going to put my center here. And then I'm going to go up 2, which is a point, down 2, left 2, which is another point, and right 2. I'm going to draw the best circle I've got. And there we go. So my solution are these 2 spots that they intersect. So my answers would be -2, 0, and 0, 2.